Hi, how's everyone doing today? I would like to show you today a tool that I use for machine learning. It's called Palladium. I think you may not have heard about it, but I think it's actually quite useful. So let's take a look. And what can we use it for in terms of machine learning workflows? So let me just open up a shell here and we'll do it as we, we'll take a look as we program. So let me create a new directory here maybe. I'm going to call it Palladium. And then maybe let's use a Python 3, create a virtual environment herein. So we can activate that. And sometimes we will update the pip, which is coming from the Ubuntu system. And then I think now we're ready to do this, which is pip install Palladium. And we'll see what that can do for us. Palladium actually has a couple of dependencies. It's mostly a wrapper or a convenience tool. One of its jobs is to allow you to separate your configuration from code, and then also it tries to reduce boilerplate. So you can do a couple of things. You can you version the configuration, which includes where does your data come from, what's the model that you want to train, and so on and so forth. So at a minimum, what we want to do, a minimal example that we can show is let's try to use this, the iris dataset, and then see what is involved as far as Palladium, which really you'll find out we're only using Scikit-Learn, but we're doing it in a way that saves us from having to write code, which we'll maybe write every time between projects. So it's maybe a good thing. So so at the center of Palladium you have a configuration file, which is by convention called Palladium config py. So this configuration file is actually not JSON, it's actual Python syntax, which is really a matter of taste, I guess. But so this configuration file will reflect what we will usually require in a machine learning project. So one of those things is surely the way to load data. Where does our training data come from? Where does our test data come from? That's one of those questions that you have to answer. And we do this within the configuration file. So let's take a look. There is some. So this configuration consists of a single dictionary, okay, so or an object, if you will, and that dictionary contains some keys which have a special meaning. Now you can have also other keys which you use for yourself, but there's convention around some of those keys which Palladium will use to find out where is your data set, for example. So this little entry here would, for example, tell Palladium where is the dataset loader, where is the dataset coming from. Now we're talking about loader because this is Palladium is a little bit it's using components. So we're not only specifying like where is the dataset, but we're also giving it a hint telling it how to load that data set. And how to load it, it's essentially given by the class. So there's a class behind here, which is gonna actually load the data set. So this is why we talk about components. There's this little key which has a special meaning within Palladium config files, double underscore factory double underscore, and this will denote that class that takes care of, in this case, loading the data set. So we happen to know at this point that Palladium comes with such a component. Palladium, I think it's dataset table, okay. At which point really we should take a look at the documentation. But for now, let me tell you before we switch over to the docs of Palladium, that table is essentially, I guess, it's a CSV file loader. So we're gonna have to specify not only here the component, the dataset loader train class that is taking care of loading the data, but we'll also need to tell it to where do you find that data. So give me a second while let's take a look at the okay, so we're back looking at the Palladium docs. Let me show you that there is some documentation around here. For our purposes, let's take a look at the tutorial, which actually does something very similar to what we're going to do here. So take a look. There's a file iris.data, which is really coming from this is the iris dataset, which we're going to use. And then I'm gonna take a look at the example over here as far as the configuration file. So here's a dataset loader, remember, and then let me just copy this over and we'll take a look at what this does. All right, so here we're back. I may only need this part of the config at this point. It's a little bit verbose, but we'll take care of what does it actually mean in a bit. So where does the data come from? We have to tell it, like, what's the path. Here we're also telling it what is the names of those columns. Now what you're seeing here is actually forgive me, I have to copy over the iris dataset. I'm going to do this right now. Whoop. So now it's inside of my directory. So what you see here is actually, so under the hood, Palladium dataset table will actually just use, out of pandas, the very popular read CSV function. And maybe if you've used that before, you'll see that these are actually just the same. So it's gonna just, call read CSV for us. This is what this dataset loader does, except, it sort of allows us to plug into Palladium in a way that it will return, that CSV data essentially in just as a, I guess, data frame, and then pass it on to whatever we want to do with it. So whenever you're looking for the meaning of these arguments, in this case, you may as well look for the pandas read CSV. And here's the idea, right? We don't want to hide any of the tools that we work with, because they're actually great tools and they're neatly documented. There's no need to sort of do anything of ourselves over here. So we're just standing on Panos' shoulders, if you will, at this point. The reason why we have to be a little bit verbose over here is just that that data, iris.data file, happens to be a CSV file that does not have any column names. Okay, so we can take it as it is and sort of work our way around that fact. We might as well change the CSV file to make it easier to read and to include the column names, but this is just to show how this stuff could work. So here's the column names. Note that we have 5 columns, 4 numeric ones, and one that is a string, which is going to be our class name. And then we have a target column. Now this target column is actually specific to the Palladium dataset table dataset loader, because dataset loaders also take care of saying this is the X and this is the Y, or this is the data and this is the target, which maybe you're probably familiar with these terms. Here's the thing, it will grab 100 rows. Okay, so consider this like a sort of a hacky way, as for the purposes of this tutorial. But we're going to say that we're going to just take like the first 100 rows and use these for use the 100 rows, and then use the rest of it maybe for the test data. Okay, so we want to have this train test split. In this case, again, it's sort of a hack, because we should be really making sure that there's a good split, train test split, but that's for another time. What we have here is dataset loader test, which we really want to say, hey, can you maybe just use the rest of the iris data file? And if you remember from Panos read CSV, it has an nrows argument, but there's also another argument which is, I think, skip rows. Let's take a look at that. So that will be pandas read CSV. Let's take a look. There's a ton of arguments, very useful. And there's going to be nrows, right? But we also have skip rows. So I think what we want to do in the case of the test dataset loader is to say nrows equals none again, because in that case it will just take all the rows that is available. But we do want to skip rows, which means that skip the first 100 and then take the rest of them. Let's try that. So this is the two arguments as far as that. Wait a second, that was called skip rows. 100, right? And so here's a neat trick. We can copy the rest, right? We don't have to repeat ourselves. Take a look. Forgive the inconsistent quoting over here, but I can essentially do this, which says, it's equivalent of copying all of this, including this factory entry, and then overwriting those other bits of the configuration. So now I set nrows to none, it's no longer be 100, and then skip rows 100, which didn't exist before, so it's going to be added. So that's fine. But so what's missing here? So we're good, I think, as far as dataset loading. We have a train and test set. But what we obviously also need at this point is a model, right? So let's take a look at the tutorial. Actually, I don't remember which model I used, but notice that we are setting ourselves up here for a classification problem, right? The target column is one out of 3 classes, and then so hopefully it's straightforward to define a classifier that will allow us to, given the 4 inputs, hopefully it will be able to say, what is the species. Let's take a look again at the tutorial for that. So there's the model, logistic regression. This may sound familiar if you're coming from Scikit-Learn. At this point, we can refer back to Scikit-Learn for its great documentation. But what are we doing here? So in this line, we're saying, hey, this is the model. And again, this is like one of those special keys that Palladium will look for. Now, when we'll look for that, it looks for those keys when we're using the CLI. When we're using the command line interface, this is where it finds stuff. This is how it finds stuff. So we're basically going to point it to the configuration file, which, because we called it Palladium config py, is going to be found just like that, because, this is one of the default places where it's going to look. And then it's going to take a look inside, and, if we're asking it to fit, then it's going to look inside this configuration file. It's going to look for the dataset loader train. It's going to look for the model, and then, just instantiate, in this case, the model, which is coming out of Scikit-Learn, with arguments that we're giving it. And then, maybe, I guess even before that, it will load the dataset, and then we'll call fit on those. So the idea here is, again, it's nothing magical, but it will do things for us that we will normally have to do by hand. So, and it's actually quite nice if you have sort of this streamlined way of doing things, and you remove this little bit of boilerplate. It's sometimes even worthwhile it, because you will have a way to, a better way to communicate and share code with your colleagues, because here's sort of a minimal but sort of a uniform way of defining things. There's a couple of these frameworks out there. I'm thinking of Hydra and maybe MLflow that are trying to do the same thing, I guess. But this is just another flavor of that. And I guess we're ready to continue taking a look at what the CLI looks like, right? So on the right hand side, let's go back to our shell. We did a pip install of Palladium, which means that it will have installed a couple of scripts into our bin directory. And one of those scripts is going to be pld fit. Okay, and try and call that. Whoops. So I guess we were a little bit too quick. What happened is that it gave us an error. So this is a Python traceback, which, it's really good to I guess, embrace and be able to read the information that it's trying to give you. But here it's saying, so one of these things it tells us is that fit is missing one required position on your model persister. So we actually forgot one thing, which is how do we save the model? Okay, and then it's also telling us, wait, did you give me the right config file? Well, actually we did, kind of. So much for helpful error messages. But the thing is, so we have still one question to answer here before we're ready to fit our model, which is, how do we actually save the model? Because fitting a model is fine and all that, but how do you, if you're quitting the CLI, you're quitting your script, which is how the script works, right? It's going to fit and then it's going to stop. It's not going to hang in there. You actually, without telling it where to save the model, it's not going to be super useful. So let's take a look at that. Where's that model persister? Here we go. And again, this is a little bit of convoluted. I'm gonna try and reduce this example over here because we don't actually need all that stuff. This is for another time if you want to take a look at the tutorial. I'm gonna make it a little bit smaller here. So the thing is, here's how we define, how for Palladium, how to store the model after it's been fitted. And you know what? Model persister, it's also going to be useful once we're happy with our model. Maybe we're seeing good results. Maybe we're confident with moving forward with our model. Maybe we're even going to put our model into production. We can continue use this framework, and so parts of this framework parts of Palladium are actually concerned about serving our model, which is this thing. This script has a def server, which sort of suggests that it's a server. So it's an HTTP server built into Palladium using Flask that uses the same configuration file, but at this time, maybe if you're running the def server, it's not going to use to use a data set, right? The train data, because it already assumes that you have fitted the model. But what it will do is it will actually use the model persister. So you have like this sharing of bits of the configuration between the different scripts of Palladium. Anyway, let's talk about the model persister. Again, we have this little component that is built in. And by the way, you can take a look at the source of these components, and you'll notice that some of them have a lot of features, but essentially you can implement your own, right? So let's take a look at the database model persister, which actually uses, I guess, SQL Alchemy to store your model as a blob. There's some stuff inside of here which is not for this tutorial. We don't want to talk about this, but maybe we can see. I guess there's no. Yeah. So consider that there's a S3 dataset. There's an example of a dataset persister here, maybe, which you can take a look at. This one will. Where's the arguments? You see, this one takes a path to a S3 bucket, I guess. We'll have to look at the docs for how this works exactly, but my point is that you can, go ahead. These things are fairly well documented. Take a look at the interfaces file, and it will tell you, hey, this is a dataset loader, and this is what I expect you to do. So you can go ahead and create your own dataset loader or your own model. Notice that the model has predict and predict proba and so on, which is just the same as Scikit-Learn. And then there is also model persister, which can read and write essentially, and a couple of other things. So you're free to extend or write your own little components for these things, which is sometimes very useful. All right, let's go ahead. I think we are ready now. Finally, model persister. Let's do it. Okay, and it gave us a couple of log outputs. It said wrote model with version 1, so that's cool. Let's take a look at the directory. Take a look, rs model db, right? And so at this point, like if you remember, we had a couple of scripts here. One of them is pld list. So what does that do? It tells us what's the models that you have there, along with some metadata that those models may be saving with them, which is again, extensible. So this is trying to keep track of, keeping track of what models you have and which ones you train. I guess you're also encouraged to use Git to track, you know, your configuration files, so you can have a hash whenever you have sort of a experiment, and you can track those things elsewhere. It's not really Palladium's job. I mean, it's not within its scope at this moment that to really keep track of those things. I mean, but you know, it's a pretty maybe straightforward path from this on to being able to you know, track your experiments. So you know, I should maybe say that those configuration files are also extensible in a way that you can have multiple configuration files, and you can have a base configuration file, and then you can have maybe different configuration files for the you know, different experiments that you're running. So this is all pretty straightforward. Let me see. There's this advanced configuration bit in the docs, which will tell you about exactly this. You know, you can have environment variables in the config, just like that. You can have Python expressions, of course, which is sometimes nice. And then you can have multiple configuration files, which allow you to, you know, split up, you know, according to how you want to version things, or, you know, according to the concerns. Maybe there's a config for the data, and then there's a config for the model. And then you can also, what we already showed you, you know, copying things and overwriting things, which also works across multiple config files. So I mean, I'm pretty happy with how those things work out in practice. But you know, so maybe we should also, because yeah, this is a little bit opaque. How do you know, PLD fit? PLD fit has a couple of things, you know, as you know, there's also PLD tests and so on. So you're ready now, I guess, to explore a couple of those scripts. But one thing I should still mention is PLD fit and then evaluate, which let's take a look at what that does. So it fits another model, right? So you notice it will tell you there's a second model now, but it will also tell you scores. So this is the score of your model, of the fitted model on the training data and test data. This is of course sort of a toy example here, but the thing is, scoring, the way that the score is obtained, can be configured as well in the config file. So that is useful because, you know, different problems require different scoring, or different you know, ways to say how good is our model doing, and more. You know, I don't think I've forgotten anything. Thanks for watching. You know, if you have any questions, feel free to reach out. I'm gonna put some maybe links below the video.